Okay. So what we did last week was an independent project analysis. Okay. So we did an independent project analysis. We determined that we should accept a project based on a minimum acceptance criteria. So NPV was positive, so we said we should pursue the project. Now, that's not necessarily the only way to do things. What if you had to compare that project to another project? To not MRI machines, that we have so much money, let's buy a clinic and duplicate our services. Okay. So in that case, we're going to compare two projects. We call that mutually exclusive project analysis. So you're going to compare them and you can only pick one of them. That's called mutually exclusive project analysis. So like you have alternative vendors of accounting systems and you got to choose which one is the best. So with the NPV, how do you think you would do that if you were using NPV? Which one would be the best one? So let's say you got an NPV like that. Which one would you pick? And if you're comparing two alternative accounting systems?
I think the second one, I don't know.
What was the rule for NPV? What does NPV mean again?
Net
present value.
Net present value. And it's a measure of profit. It's a measure of benefit, right? The benefit versus the cost, remember. So which one would I pick here out of these two? Which one has more benefit?
The
higher one.
The higher one?
Yeah.
Well, I was going to say the mutual exclusive.
Oh, so that's throwing you off? Okay. It means that you can only pick one. You only pick one. You can't have both, even though they're both positive. And
okay.
So it's a little bit different. You have to pick the highest one. Okay, so you pick the best. You rank them. In other words, you put them in order and you pick the best one.
Highest value, okay.
Mm-hmm. Okay, and now, so there's independent project analysis, where you just look at each project in turn, and anything that has a positive or profitable NPV, you just pursue it. There's a mutually exclusive project analysis where you have to pick only one. And then there's what if you just work with a budget and you're told you have $3 million and go and spend it. So you lay out all your different possible projects, all the different things you could invest in. So the MRIs, the clinic, maybe some telemedicine, a wing or something like that. So you want to compare all of those, or you want to calculate the NPV of all of those, but then you can only pursue those that are within the $3 million budget. So you can do more than one, but you have a budget that restricts you. So those are the different kinds of, this is the most realistic, right? Capital rationing, you have a budget and you can invest in more than one, but not all. Any questions? So this is just some terminology. All right, so you get the idea from last week that valuation, we're valuing the MRI project in the example that we did last week. And And there's an art to it. Yeah, okay, we're doing mathematics and it looks kind of scientific, but really it's based on your estimates, right? It's based on gathering and imagining the future and what it would be like. And you could use previous experience, and you could look at what others, or you can inquire what other departments experience, right? So you're using previous information and imagining the amount of each cash flow. You're also coming up with your risk adjusted rate of return. In other words, your interest rate that you're going to use. And you have to be aware of the timing of the cash flows. And your assessment, your analysis is just as good as your estimates, really. Okay. It depends on those. So I call this the art evaluation. This RRR represents the required rate of return, or the risk adjusted rate of return. That's what I call it. So this is just your I in the formulas, your interest rate. The opportunity cost. So we already learned about the NPV, so I'm just summarizing here the NPV. We take the initial investment, as this would be our cost. And we compare it against the present value of future cash flows. Or in other words, the benefit. And we do this all in time at time zero in the present. This is the present value. Everything has to be in the present. So I call it cost, or present value of the cost. And then that's the benefit. And to estimate the NPV, we have to estimate the initial cost, because we haven't necessarily purchased it yet. We just get an idea of what it would cost. We estimate the future cash flows. How much would they be? When do they happen? And we have to estimate that discount rate, or that interest rate that we're using. Remember, we call it the discount rate because we're doing that divided by 1 plus I, that discount factor versus the accumulation factor. Anyway. So yeah, I has a lot of names. You're going to learn it has a lot of names. You can call it the discount rate, you call it the interest rate, you call it the opportunity cost, call it the required rate of return. Okay, it has, in different contexts, it gets a different name. And so how do we use the NPV? We just did it. This is a review. We're going to accept the project if the NPV is greater than 0. If we're just evaluating the project on its own merit, or independent project analysis. And otherwise, if we have to compare 2 projects, we just rank them and pick the one with the higher NPV. Everything okay so far? So review. So we have an example. Let's do this example together. So here's my example. And we're not going to have, I'm not going to give you all the information like I did last time. I'm just going to give you the cash flows, okay? The projection of cash flows. So someone figured out this information, all this information, and they end up with investing this amount. So you can think of 3 zeros at the end. So this is like millions of dollars, but to make the calculations easy, I'm just going to write like 1,100. So this is an investment. This is the return that you think you should use. And then these are the net revenues. You see what I did? Revenue minus expenses equals the net revenue. Okay, so now what do? You guys take it away. Calculate the NPV. Use Excel. Try and remember how to do that. Make notes for yourself. And then I'll pick it up from there.
Sorry, what are we calculating right now? I think I lost you.
I'm sorry, did you hear what I said? I'm sorry, my microphone was off. I just said the NPV we're answering, TY.
Okay.
Did you get it already?
I'm not sure if I'm correct, so I don't know.
What did you get?
I'm afraid.
You're afraid? You're funny.
So I was going with the first formula that you put up, minus NPV equals minus initial plus total and future values. For my total future values, I had 1477.02. Remember you said we're not putting all the other zeros? So if I removed minus 100 from it, it's 377.02. I don't know.
Dun, da, da, you got it right. Yes. Very good.
Thank you.
Very good. Thank you. I'm sorry, my microphone was off. There was some noise on
Oh,
this
it was
side.
1477.
Wait, what was the answer? Oh,
I'll
sorry.
show you. I'll show you in my Excel.
Okay,
I'll show you.
okay. Because I
Okay, here we go.
did that for each year.
All right, so I did it two ways. One way was I took the initial investment and I added, and you have to put the plus right near it or it won't work. NPV and then bracket, right? You have to put that rate first in a decimal or as a if you put a percentage there, it'll work too. And then the numbers, and that will give you this answer. 37702. Who was able to get it? Lydia, does that mean you got it? You put her hand up.
Someone else got it because someone else was talking of 1477. That's the way.
Uh-huh.
Yeah, that's as far as I got. I got the 1477, but I didn't realize I had to add the
Remove
11.
the first one.
Yes,
Oh.
yes, you have to add that. You have to take off the cost. So the formula is initial cost
Mm-hmm.
plus NPV. And that's, and you can't put any space there or it doesn't work for some reason. Now, the other way to do this, I think, anyway, if people like this, you can make a little, a table. So you can write a table like this and then make the formula. So I'll show you in real time. So I say equals, then I touch here, that's the initial investment. Then I add, I write NPV open the bracket, and I have to put the rate first. You can put it as a decimal, you can put it as a percentage, it should understand. I think that will work. And then I'm gonna highlight these four and close the bracket. That's another way to do it. See, that's confusing. I think I'm gonna use the decimal instead because it is not liking that. So, but it's still weird. Why is it doing that? It's taking it as a percentage. So when things like that happen, go to your formats, fix your formats up. So I get the same answer. It should be in dollars. NPV is in dollars. I'm erasing this. What is this? So that's using this formula. Equals plus NPV, and then I just touched the cell to get 667 to C6, sorry, to C, I can't say that, C6 to C9. In other words, these, that's the cell, C6 and C9. So, I don't know why it's looking weird like that. You get the same answer. Questions?
I missed how you did the, you just put C6 and then colon C9 or
Okay, what I
you
did,
just-
okay, watch it again. Okay, I'll do it again. So equals. And then I just touch, so I use this table here as opposed to having to memorize. You're not memorizing the C's, right? You're just going to touch here and it comes up by itself. And then add, and then use the function NPV and open the bracket and follow the direction. You have to put the rate and then comma. You watching, Barbara? And
Yeah.
then you touch here to here. And you see both colors are showing. It's just what Excel does. And when you make a formula, it color codes everything so you can check back and forth. So you can see the red are this, or the pink are C6 to C9, and the blue is the initial investment. And I close my bracket and enter. So
Okay.
if you like that better, you get the answer.
No,
You don't like it?
no.
Yeah, just do whatever you like. I gave you two options here. As yeah, because that's involving another function that you probably maybe don't want to learn. So just that clicking around the reference, it references each spot with the name, a label, C7. This one is C9. This one is C5. Okay, so I can put that in the notes though. So what I have, I can add that to the slides. Let me put I'll save that and I'll add it in, and I'll revise these notes a bit. Okay, so I'm going to go back to my notes. Everyone's okay with this? You guys got the number? Rhoda, Lydia?
Yes, I was just gonna ask you, is there a way to compute this manually? Because I don't have access to Excel at the moment. So, I mean, I wrote down what you just did now with the table because I found that helpful, but is there a way to demonstrate this?
Of course, it's all a formula, remember? It's all comes from a formula, but we're doing this because it's
That's what I
easier.
was doing.
This is
Yeah,
easier. And you can also use a
Uh-huh.
financial calculator, but yeah, so I'll show you the next slide is just basically the formula. And you can use a basic calculator. Oh, no, that's not it. Oh yeah, no, that's not it. Sorry, do that again. Okay, so you see the formulas there. This is the formula here that we plugged in to get this number. That's basically what Excel is doing. using that formula. It's just each cash flow is discounted the number of periods away that it occurs. Is that okay? And
Yeah, I
there's
got
the
it. Thank you.
the 1477.02.
Yeah, of course, I see it.
And since it's the total or the NPV is 377.02, this is greater than 0, so we accept this project on its own merit, independent project analysis. We don't compare it to anything else, just to 0. Okay, so there's the formula. I'll add in the other bit. And I'll put that image there later, like the one on the spreadsheet. Okay, so NPV gives you a dollar amount and we
All right, can you go back? Oh, wait, it is still there. I thought you took it away. Sorry.
Okay, you want to copy that? Okay.
Okay, thank you.
Thank you. Okay, so that's NPV gives you a dollar amount. And we understand that as a profit, but it's kind of, it takes some calculation. Sometimes there's investors or you're working with people who are making, part of the decision making who might not understand what we just did. They don't understand what NPV is. They don't know what discounting is. They don't understand finance. And they just want to know, if I invest in this, when do I get my money back? When do I recover the costs of this investment? So that's another approach. It's another piece of information in the end. But I'm going to teach you how to calculate that amount. Like, how do you figure out how long it takes to recover the costs? So we call this the payback period. How long does it take the project to pay back its initial investment? Now, I'm going to see it's pretty straightforward, but maybe with getting a little more precision than is what I want to talk about anyway. So we define the payback period as the number of years to recover the cost of a project. And we can do this as an independent project, saying, okay, look, we have the strategic management team that's going to look at possible investment alternatives or expansion alternatives, or to make us more competitive. And we're just going to pursue all projects that pay us back in a year, because we have this big investor and he's going to dump us, he's going to give us some money, he's going to dump some money on our laps, and we're going to invest in everything that pays back in a year. So that's one approach. Maybe though, that a different approach would be that you're just going to take one project from the options and have the one that pursue the one that pays back quicker. So you have to have a very refined way of comparing the payback period. Right? So let's see an example. And again, I'm not going to make it too complex. I'm just going to show the projection of cash flows. So here is my projection of cash flows. And looking at this, just common sense, when does this project pay back? What year? When do you get your $1,000 back?
Third year.
After the third year. Oh,
Well, in the third year, right? Because these are always assumed end of year. So this will be in the third year. But I want to know a little more specific detail about when it pays back. It'll be in the third year, but at what point?
Oh, okay.
So let's figure out how to do that together, right? So we're going to call it the payback period. And we're going to say, okay, it's going to be 2 years plus something, right? Because it's in the third year after the second. So to figure out at what point or some measure of when it pays back, we're gonna take the remaining amount and divide it by the cash flow in the third year. So I'm doing this very specific to this problem just to make it easy, but if it was a different year, you would use a different number here and a different number here. So this is specific to this project that I put a 2 here and a 3 here. Is everybody okay about that? So let's see, what am I talking about remaining amount? Well, from 6, so what I did was I put the cash flows here, and then I added them together. I put $200 at the end of the first, but then with an additional 400, that's $600 by the end of year 2. And then add the 700, that's 1,300. So that's how I got this accumulated cash flows. So from 600 to 1,300, the remainder, what remains is how much? Oh, sorry. It's going to be the 1,000 minus 600, right? Everyone okay with that? So we need $400 more to recover our cost. So I'm going to put the numbers in. That's 2 plus 400 divided by, what's the cash flow in year 3?
Would you do the 1,300?
So that's the accumulated cash flow, but just the cash.
Sorry, 700, sorry.
Right. No, no,
700.
I'm glad you put it out there, Patty. You just went for it. That's good. So that's 700. Do you understand why I did that? So I'm going to say, what I'm doing is I'm spreading out the 700 over the year. And I'm saying, you know, when do I hit 400? At what point in the year? So I'm going to try and get a decimal here. And that will give me very precisely the payback period. So what would this be? 2 point. So you're just dividing 4 by 7.
Okay.
I don't understand if you're looking at the remaining amount, which is the 1,000 minus 600. Why did you put a bracket over the 600 and 1,300?
Yeah, because it's, I know it's confusing, but I'm trying to say it happens in there somewhere. So I don't know what symbol to use. Let's see.
Is it
I can just say
is it
remaining amount
0.5?
between,
0.57?
yes. So it's going to be 2.57. So it's going to be like, so half of the year would be June, right?
Mm-hmm.
So
A little,
it pays
almost.
back after June, just after, like before July.
Okay.
Between June and July. That if we're using the calendar years as our for our budgeting, just assume that makes it easier so we can talk. Okay, any questions about this calculation? Because I'm going to do it again. So So the payback period is in units is years. So 2.57 years. And then what do we do with this number? How do we interpret that number?
Do you mean like transfer it to months or?
No. I mean, what does it tell us to do? What is the recommendation once you see that number?
Oh, and after more than a year and a half, 2 years and a half, we'll see payback.
Uh-huh. We'll recover our costs. So if management only pursues projects that pay back in 2 years, what do you say?
They won't
This
do
would not qualify.
You're right, we reject. But if management pursues projects that pay back in 3 years, it would
We can
qualify.
accept.
Yes.
Okay.
So this is very practical. Most investors will ask that. So it's good to have this number. Again, it's all based on the estimates. If these are not good estimates, then the payback period is not a good estimate. All right, so you might want to, if you had to present this to somebody, they might present you a series of cash flow projections and show you that no matter what we look, however we look at it, it's going to pay back within about 2.5 years. So they make some sort of statement like that. If management only pursues projects that pay back in 3 years, we say accept. Okay. Okay. All right. So what's wrong with this method? You should feel like, well, I mean, I hope the calculation was easy enough, but what could go wrong with this estimation, and why is it that I taught you about NPV and I told you it's a convention, it's the conventional approach in finance. Why did I not mention this before?
Because present values are constantly changing, and
Well, I didn't even
this
use,
is like,
yeah, go ahead.
well, I just meant like what you're presenting there, cash flow year one, because these are just projections, right? These are not.
Okay, so one weakness could be the projection itself, right? But that also, NPV is also prone to that kind of error. So that's not distinguishing this one. But what distinguishes this as problematic, possibly?
What if the market change?
But that NPV would also have that problem, right? So what's distinct about this that's a problem about doing this? So we're going to talk about the disadvantages of this for a moment.
The disadvantage is it's too easy.
Well, some people think it's easy, but it is, yeah, we never did account for time value of money. So that's a problem. Like we didn't even care. We're like, oh, just jump into this and calculate. We didn't do any time value of money, discounting of anything. We just went for it, right? Because we discount because we know future cash flows are not worth as much as the current ones. So we didn't even think about that. So that's kind of a problem. What's another problem?
Interest rate.
Well, that's again, that's also going to be a problem for NPV. So what's distinct? Disadvantage, yeah, so I'm just going to tell you, right? So it's not easy to see this at first, but let's say this amount was like that. Did I even use that number in my calculations?
No.
So I just stopped here, right? At 2.5 years, 2.5. I just used these numbers. I didn't even use this number. But don't you think that number is important?
It is.
Yes. So even though it's paying back in 2.5 years, you want to be able to tell people who are making the decision or your team that if we hold out, we have 4,600 coming. So, let's extend our payback. Sorry, let's extend our cutoff, right? Let's just wait for that. So the problem in a few words is that it ignores future cash flows. Yeah, it ignores the distant. Can you read that? So it ignores large or detrimental future cash flows. Like, what if this was a negative? I didn't even use it. And I haven't even told anybody that we're going to make this is a waste of time. We're going to lose all this money in the 4th year. So that's why you wouldn't, if you even use this, you would use this with the NPV because the NPV looks at all the cash flows. Let me remove this to avoid confusion. I'm going to make a note here. Okay. So those are the two main problems. And inside of this also, the problem is that, like I've mentioned, is that decision of management is pretty arbitrary. It's not like, NPV greater than 0, go for the project, right? It's not like that. Sometimes management will say 2 years is anything that takes more than 2 years, we're not going to pursue. Anything that takes more than 3 years, we're not going to pursue. Or if they see a really large windfall in the 4th year, they might just change their threshold. So the problem is that it's arbitrary. Okay, the cutoff is arbitrary. It's not like NPV positive as a rule. It's arbitrary and subjective. That's the problem. Okay, so those like 3 kind of disadvantages, and we can fix the first one by actually discounting. We can fix the second one by just presenting payback period with the NPV analysis because they're 2 different pieces of information, right? This is interesting information to the decision makers. And then there's not much we can do with the cutoff, but again, using NPV together with the payback is helpful. Any comments or questions? Did you follow? You guys with me? So what I'm going to do next is let's do the what's called the discounted payback period. So we're going to correct for that first problem by calculating what's called the discounted payback period. And so taking the same cash flows, what I have to do is discount each one. So how did I get this column, this new column here? So I calculate what's called the present value of each cash flow. So I convert each one of these into their present value. And then I do this thing, the accumulated discounted cash flows. I'm going to move this up. Here. Have to erase that. All right. You see what I did there? So again, so now I'm just going to use this column and I'm going to add. So the discounted cash flows in year one are 182. The accumulated discount to cash flows in year two, I have to add these two together to get that. And then this amount is this plus this. And so on. I hope that makes sense. And then like last time, I look for the 1,000. So now what is the answer? When does it pay back?
After year 3.
Try again. Just before year 3, just before, you see, because by the end of year 3, it's 1,039. So just before year 3 ends. If we spread out the 1,000 over year 3, that's the approach. Do you follow? So I'm going to take the same formula as before, the remainder. So that's going to be what's left. 1,039 minus 513 is 487, divided by the year 3 cash flow, 526, and then add it to 2. So now it's just before end of year 3, it's 2.93 years. So I can give you an exercise like that for your next assignment. I'll post it. I'll post it tomorrow. So you can make that calculation. You don't have to memorize this. It's just understanding the logic of what they're doing. You know, if somebody says that it pays back in so many years. It turns out that executives like to see just the payback period. They don't even bother with the discounted payback period because in the end, this is always presented with the NPV anyways. So you get the information, pretty much what you need from the payback period.
Sorry, I'm a little confused about something.
Yep.
Verbally, you said 1,039 minus 513, but
Oh, sorry,
I don't know.
1,000. Sorry, you're right. Yeah, I keep doing that
1,000.
mistake.
Okay.
It's
okay,
1,000, just
okay,
like last time.
okay,
Thank you
okay,
so much,
okay.
TY. Yeah, it's just same as this one.
Okay.
The remaining amount, it was here, the 1,000. So what we have done so far, we've talked about the NPV. The NPV gives you a dollar amount to decide if you're going to pursue a project. NPV must be greater than 0. For the so we did the payback period, and that gives you years. And you have to make sure that the payback period is smaller than some, something set, some cutoff. And then you can do the same thing with discounted payback period, gives you years, and the same thing. You calculate it. So I call this one DPBP, doesn't really matter. You know what it is, and you check if it's less than a cutoff. And we've resolved the issue of of discounting and accounting for time value of money, but still the other two disadvantages still exist, that it ignores large or detrimental cash flows, like good ones or bad ones. And the cutoff is arbitrary. It's not like the NPV where it's objective.
Yeah.
Huh? Question?
No, thank you.
Okay. Don't worry, most of the things I write are usually in the notes, so that's what I just said. Okay, questions? Any questions, comments? You see the usefulness of that?
Want to know when do I get my money back?
And then, possibly begin to see a return on investment beyond getting my initial expenditure back. All right, so now we're going to talk about the internal rate of return. So this is the third rule, where NPV gives you a dollar amount and the payback period talks about years. This is a different metric or a different unit that we're going to get. What you're going to get out of calculating the internal rate of return is a percentage. I'm going to teach you how to interpret the percentage and the value of doing it. Okay. So what is the internal rate of return? The internal rate of return is the interest rate that solves this problem. What is this?
The
NPV.
Exactly. So it's setting the NPV to 0. And you would solve, so you're obviously you cannot do this mathematically on a piece of paper. This has to be done with a computer. Okay. There are actually calculators that can solve this, and Excel can solve this, and other softwares can solve this, right? But you can't do this by yourself. You cannot mathematically or algebraically solve this. So I'm going to show you how we go about finding this, it's really important. The main reason it's important and useful is because it gives us, it ends up giving us a range of discount rates or interest rates the firm could use to approve their project. In that way, they don't actually have to come up with the interest rate they're going to use.
So in this, there's no interest rate?
Not to calculate it. We're not going to use an interest rate to calculate it, but we're going to use an interest rate to interpret it.
Hmm.
Okay, so, all right. So what is this doing exactly? So I can think about it as this, or I could put the 2,200 on the, I could add 2,200 to both sides and get this, whatever. Either way, what we're doing is trying to find the rate that offsets the investment. So let's see. What happens if I make this number bigger? if I make this number bigger, what happens to this whole quantity? Does it go up or down?
Goes down.
Explain why it goes down, TY.
Because if you're dividing with something, if it's small, the real number goes high. If it's big, the real number goes down. That's just why I
Yes,
said
so
that.
it's the opposite, right? If you're dividing by a bigger and bigger number, the whole number goes down. So all this will go down as the IRR goes up. So as the rate goes up, this whole thing will go down. And is that a good thing? Will that make this 0 or not? What's a way that I could actually make this be 0? I want the opposite, right?
Positive.
Yeah, I want it to go positive. I want it to go up. So I have to do the opposite. Let's see. So I want this, so let's work backwards. I want this to go up. So that means these have to go down. And as these go down, this becomes bigger and it will offset this and give us 0. But if you look at the numbers here, if I just add these, ignore the bottom. If I just added these together, what would I get? Would I get more than 22,200?
Yes.
So if I just added them, I would get more than 2,200. So
Mhm.
let's just start. Okay, so I just talked about the mechanics. So let's just say, what if IRR was 0? What would happen? So in other words, if I made this all 0 here, then
Mhm.
you get exactly that. You just add them together, right?
Yeah.
And
You
it's
would make
bigger than 2,200.
1,006.
So how
Yes.
would I, so this is not going to be 0. What's the net if I add all those together? It would be a positive.
It'll be 1,6.
Mm-hmm.
So how would I make it be 0? What should I do from 0? What should I do to get this to be 0 together? What should I do? I should go a little higher, right? So this will be higher. And then the overall numbers will go down just a bit. I don't want to make it too high, but it's got to go higher so that it will make 0. Okay. So if I start with IRR 0, I'll get a positive, but I don't want a positive. I want 0. So I'm actually going to do it the first way where I'm going to say just a little bit higher, keep them going a little bit higher until it crosses. That's what the calculator or the computer is going to do. It's going to iterate. This is like an iteration. And even Excel will iterate. And you have to give it a starting point for its iteration. And hope you see the value in this. So here's my example I'm going to start with, right? So this is the initial outlay. These are the cash flows. And I call this an investment project. It's an investment project because I invest this amount and I see these cash flow returns. They're all positive. That's pretty basic, right? But I'm going to change that. So that's why I'm defining it here. All right, so let's see. This is called the NPV profile. It shows what the NPV would be. So I'm going to take this formula. So as you guys told me, if I just put 0 in here, it'll make 1,600. No, I can't use that one. I have to use the other one. I have to use this other one. I need to clean it. Give me a moment. Okay, so if I put 0 in here, I get 1,600. That will be the net. Everybody's good with that, right? So what I'm going to ask you to do, and we can generate this. We can make this table in Excel. Can you guys do that? Make this table with rates and NPV? I'll do it with you.
Like literally just write it out just like that.
Yeah, exactly. Make it like that. So I'm going to do it with you. I'll give you a head start and then I'm going to show you what I've done because I don't want to go to the Excel spreadsheet so you guys can see the numbers. I guess have you downloaded it or no? You're just following me.
Downloaded what?
The notes. I put these on the
I'm just following. I'm just following you.
Oh, okay. So then I'll let you look at that so you can try it yourself. And I'm going to prepare my own spreadsheet here.
Wait, you put it on Blackboard?
Yeah, it's on Blackboard.
Okay. If you're doing this on Excel, I would like to watch you though.
Yeah, just copy the numbers or something so that you guys have it. Just put it on a piece of paper. Put down. So what I want you to do is copy these numbers down on a piece of paper.
Well, I did already, but I'm not used to making a table on Excel, so I
Okay,
wanted to watch it.
okay, so just copy these numbers down and then I'll do it with you. We'll do it all together. Okay. Okay, so I'm going to go to my Excel. Okay, so that's my data. Everybody's made a table or no? Okay, there's my table. I made it centered by pressing these here. Center everything. And then I can make them dollars by pressing here. And then what I want to do is make what's called the NPV profile. And that means putting the discount rate here and the NPV here. So for different discount rates, I'm going to calculate the NPV and make it that table that we were staring at. So this thing is called, what we're doing is called the NPV profile. Okay. So I'm putting numbers in here and the numbers that were used in the notes were just going by 5. So 0, 5, 10, sorry, let's do decimals, right? So 0, 0.05, 0.1, 0.15, 0.2, 0.25. That's it. And I want to make them all right. Let me know when you caught up. No. Why is, I don't know why it does that, but I'm going to leave it as decimals till I figure that out. Okay. Tell me when you're ready.
Ready?
You're ready. MPV. So you see where it says rate? I'm going to touch here. So I wanted to use the rate in that column. And then I'm going to touch these. So you can't avoid my method. And that gives you the 1600. So I'll put the formula beside. So you can see that. Okay, now you're going to have different, the thing is you're going to have different cells than me because I started over here. Maybe I should move this so everybody starts in the corner. I don't know. That helps. Let me do that. Let's see if that helps. So start everything in the corner, but you have to do it exactly like me or so I kind of don't want to show you my code because if you didn't do it exactly like me, it won't be the same answer. You could just put numbers in it. It's faster this way, but see, because I can just go like this and get the numbers right away. But let me just put the numbers in because I'll do it two ways. I'll do it with the numbers and then with the code. I got a different number. Did something wrong. 100, 800, 900, 500, 1600. Oh, because I have to put 0 first. Okay, so you could just do it with the numbers. I would like to take you to the next level, but I don't want to torture you. Okay. This is actually not so bad because all you're going to do is copy that all the way down. You could say, you see this little little thing here, my little cross. try and get that cross and you double click there and it just fills everything in. But no, that's not going to work. I'm just going to have to copy, control copy or control C, and then move it and control V. That will copy it. It's the same answer, but I have to change the rate to a 0.5. 0.05, sorry.
How do you change from cash value just to regular value? Because my 4 and 5 and 6 keep giving me a cash value when I enter the year.
Okay, I'll show you in a second. Okay, Patty, tell me again. How did I get the cash value?
No. I'm on my iPad and it just display a little bit different.
Exactly, yeah.
My year 5 and my year 6, it keeps giving me cash values. From year 2, 3, 4, it gives me regular years. But when I do year 4, 5, and 6, it's showing me cash values when I enter 3 and 4.
I just pressed this thing here, the $sign. Do you have that on your display?
No, I guess I have to just try to hit formulas, layout, data.
It should be there. Let me see. I have it on my iPad too. Let's see. It's a little bit different. That's why I don't show it, because
Yeah.
yeah. But do you also have it on your computer? Okay, here's mine. I'm gonna try and find it.
I'll switch to computer. It's fine. Let me just switch to
Okay.
computer.
Okay.
I don't want to hold up anyone.
Yeah, well, I don't want to lose you either. I'm checking it out though. It's just so bad.
Oh, I see what I did wrong. Minus.
So the cells that you use, the 800 to 1600 is the same for everyone.
Oh, okay.
This formula I did, I'm just changing the rate every time, Barbara.
That's it. Okay.
That's what I'm gonna do. I'm gonna just change.
So when you dragged it down, you're not supposed to do it that way.
I didn't do it because I decided I wasn't gonna do the referencing like I did before, but you could drag it down. You could do it that way too. I can show that later. So I'm just
Okay.
gonna change this to 10. And that's 10. So I'm copy and pasting. And then changing this number each time. I'm just putting, you don't have to put this other column in. I'm just doing that for everyone to see.
Yeah, this is excellent.
Okay, Patty, I'm going to show you, let me just show you about your computer. I mean, your iPad. I'm going to show you.
Oh, it's okay. I switched to computer.
Yeah, you don't have to use it. I'm just going to show you for future reference.
Okay.
Because I don't want to lose you trying that. So here's my iPad with Excel. It's coming. And you see this? You see the 3 dots? I think with the 3
Sorry,
dots.
I was on mute. I saw that when I was in it.
Yeah, so then you can hit cell styles. No, that's not going to work. Let's see, wait, general, no, general, hit general. And then you can change the value to accounting currency. You can make it currency. Okay, so we'll play with that later though. Don't waste that now. But you
The
can,
last number is negative. Okay, yeah. Yeah.
so where it says, it said general, now it says currency. It's changing the format of the number. So to put it back to general, it's just general. Okay?
Okay,
So work
thank
with
you.
that. Okay.
But isn't there a quicker way to calculate this than this?
Yeah, they're using the references. You mean to get IRR?
You know, like
What is the question? Is the question to do this table or to do IRR?
without having to do the table.
You have to do the table because Excel cannot figure it out.
Okay.
If you use a calculator, some calculators know how to get an IRR, but there might be more than one. So not all calculators can do that. You have to have a very specific finance calculator, costs like $60. It's not a big deal, but I'm showing you in Excel, and it's also pedagogical to show you what the calculator is doing so you know what you're getting. That's why I'm going through this. But the faster way to do this table is to do the referencing formula. But if you guys aren't familiar with Excel, that's probably confusing. So I'm doing it the long way.
Can you
So-
show the copy and paste again? Because
Okay, so I'm doing it again. I'll take I'll erase these. I'll erase all these. So I'm gonna touch it and Control C. Are you using a Mac or a Apple computer?
no,
I mean,
I'm not.
a Mac, sorry, or a PC? Are you using
Like a tablet, Surface tablet. I guess it's PC.
you're using a tablet, an Excel?
Yeah.
Okay, it's not giving you any, it's not weird. It looks exactly like this. That's good. Okay, so I copied it and then I changed the rate.
Wait, I didn't see how you copied it. Like you just Control C.
So I just said Control C and then
Oh.
touch and then Control V.
Oh, I know.
And then you
Control
go in and you change the rate each time. So Control copy. And
But
then
mine changes to when I copy it, it change the you see how yours is the 2200, mine's automatically go to the 800.
Mhm.
It goes to another.
can you can't share that. Can you share that or no?
Yeah.
So I can see what you're doing?
Okay, it says you disabled
Okay, I'll
share.
turn it on. I'll turn it on. It's just like a default like that. Okay, so I'm gonna stop share. And make you a multiple participant. Okay, go ahead.
Can you see it?
Yeah.
Okay, here. I had copied and I pasted it here and it comes
Okay.
up at
Let me see it. Double click it. Let me see the formula.
it just goes to F5, which is this
Yeah,
one.
yeah, because like I mentioned, yeah, it's gonna move. When you go down, it also goes down. So you can't do it
So-
that way. Yeah.
So I have to change it to F4.
So, okay, let me show you because if that interests you, I'm gonna show you. Okay, so let's take, you can go off and then
Okay.
I'll show you because there's a specific thing to do. So what she did is great. I'm glad she was trying to do it like that. So she was using the reference approach. Let me get my thing back. Referencing
As
cell
opposed to putting the
referencing.
numbers in. Oh, okay. Right?
I'll show you. Okay, so I finished it this way. If people want to do it this way, if you want to do it the way Barbara's doing it, I'll show you. So what can I do? I'll move it aside. All right, so Barbara she changed her formula, so she's referencing the cells over here. So she's pulling just these with a colon. And she used the touching to do it. So that's how she got that. But then when you copy and paste that, what happens is, I'm just going to double click to see, it moves down too. So how do I stop that? The way to stop that is put a $sign. This anchors it so it doesn't change from what it was before. So it was actually B3 to B4 to B6. So you got to change that. anchor them so they don't move. Wait, well, you want to go down, but you don't want to go, wait. You want to start at B3. Let me think about this. Hold on. You want to go B3 because you want to stay in the column. Yeah, you want to keep it the same. So B3 to B7, the same numbers. So this forces it to use the same, B6, sorry. So those $ force it to go to the same thing, you see? So make a note that that's what you did.
But
And-
but the first number,
And then I
the-
could change the first number, yeah, to 10, right? Up to 5. There you go.
okay. that
So
makes
now
sense.
when you copy that, so we could do that even right at the beginning. So what you're going to do is do that at the beginning, $ in the column and the row reference. So it uses the same block of values. And then what you wanted to do is also reference, you want to reference the column beside here, right? So what is this? This is well, mine is F10. So I'm going to go like this. Unfortunately, it's hard to do that. It's hard to see what you're doing because it covers it. But you know what you can do is you can look, you see up here is the function up here in this thing. That's where you can do the editing. It doesn't have to be right on the cell. Up here, you see up here in the search bar or the formula bar. So anyway, so once I do that, all I have to do, watch this, Barbara. I double click this little cross and it goes all the way down. I'll do it again, all the way down. That's really how you're supposed to use Excel. You reference the cells in this column. But if you guys don't want to do that, you can just do it formula by formula all the way down. So let me put the formulas down so everybody can see them. So then this one was F. Oh, you can't see the whole thing. There you go. So yeah, Excel is really a valuable tool. That's okay. I'm not going to show this. If you do this, actually, yeah, I'll do this. So what happens, what's different from each one? I just going down with the disk, like going down this column and filling that in as the rate each time. All right, so we made a table. You could do this by hand, but I'm teaching you in Excel. You can get some practice. And what do you see here? Okay, I'll give you guys some time to clean up whatever you're doing, make sure you can get what I got, what then we'll do the analysis. So this is the elementary way, like this is how we've been doing it so far, but I just introduced you over here. Barbara was interested in doing the referencing, but this is how you have to do it. So that you're using this column and then these cells here. You could actually even go further and call it B2, not even 2200 negative. You could say B2. So always touching the cell to get the name. All right. So this is just going down this column. Any questions? Okay, so you can create the NPV profile, and then you see that the NPV, remember what we were doing? We're trying to make that equation become 0. So it goes from 1600, and as we increase the discount rate, it's going down and down and down. That's what we said. When the denominator goes up, the value goes down, right? So it's going down, down, down. And it crosses 0 between 20 and 25%.
Yeah, 4 and 5.
So NPV is 0 between, so what this means is NPV is 0
between 4 and 5. 1, 2, 3, 4. Or
between 20
Wow.
and 25%.
Okay.
So now we can be more precise. We can use the Excel function called IRR. And look what it asks you to put. All you have to put are your values. You actually have to use all these values. So you highlight them all. And then you put a comma and you give a guess. The numbers 20 or 25 or anything between there, you can put, and Excel will iterate to find the answer. So I could put 20 in and it'll find the answer. And it'll find it more precise than 23% if you just put the decimals in.
Okay.
So I'm going to write down, I'm going to put the formula there for you so you guys can copy it. Again, you can go the long way and type it out yourself rather than doing the referencing. But by this time, I hope you appreciate what we're doing with the referencing. We're using the cell numbers. So notice I put all of the values in. I don't start at B3 like I did for the NPV. I start at B2. I put everything in there, all the cash flows, initial investment and everything.
I
Okay,
didn't get that when I did it.
this number?
Yes.
Okay,
Yes.
let me do it with the numbers rather than with the cells.
Please.
Your cells are different than mine. So I'm going to write IRR.
Oh, I think.
And then the values, I'm going to write all the values out. I don't think I can actually. I think I have to use the cells. I think I tried this earlier. It gets mad at me. I put things in. So let's put 800 and 900 and 500 and 1600. And then I'm going to put my guess of 20%. And I guess I'm going to put 0.2. Oh, I put 20. Oh. I think you have to put the actual number, not the decimals in this one. Jeez, there's no consistency. See, I get an error. Too many arguments. It doesn't like it. So you're forced. If you want to get the answer, you have to use the cell reference. So what you do is you just touch in your spreadsheet where you put or your table where you put the values, you touch them and the formula will pick them up. So I put so let's start all over. I put IRR bracket, then I touch all of them, comma, and 20%. Just put 20. So I've shown you how to do this. What I really, I want you to be able to calculate this. I want you to know what is involved. It's basically the NPV set to 0 and solving for the rate that gives that. And now I want you to do the interpretation. What does it mean? I'll put this spreadsheet onto the platform so you guys can play around with it. In case you got some, yours is wrong. You can see what I did. Is that okay?
I still am not getting that. I don't know.
You want to show me your screen?
To show you. Okay. Oh, I'm working on a different computer.
Oh, okay. Can you take a picture?
calculating.
Can you send a
I
picture?
could take a picture.
Send it to me at my phone. 787.
Okay, I'm coming, please. Seven, 8, 7.
504 0077.
Uh,
787 504 0077.
so okay. That. Okay, I'll send it to you in a second.
Are you sending it in regular iMessage or WhatsApp?
I'll send it on WhatsApp. Because your number is international.
No, it's not international, but it's okay.
That's what we said. Okay.
Yeah, it's a US number.
Send.
Well, but I need to see what it is because I just see the error. I need to see the function. So
The function is at
double
the
click
top.
it, double click it. No,
The
double
function is at the top.
and take a picture. I don't see the function at the top. I just see it says number, like it's an
Yeah,
error.
but I calculate at the top the FX part.
Yeah, but it doesn't, I don't see, oh, I see what you're saying. Okay, yeah, IRR B. Oh my gosh, I need lights. Yeah, you have to include the initial cash flow as well, and it should be a negative. You didn't put a negative, that's your problem. It should be negative
Oh.
2,200.
Okay.
That's the thing about computers, it's usually us. It's not the computer. So yeah, you got to make it a negative, and you have to
Okay.
include all of these.
Okay, I got it now. Thank you.
Okay, so what does this mean now? Let's go to the interpretation.
If the NPV is 0, you're still saying?
Yeah, the NPV will be 0 there. What does it mean? That's the question. So I'm going to
Oh.
show you in the notes. So going back to the notes. So I'll share this Excel sheet with you guys so you can explore it if you want. But I'll do that after the class. Okay, I'm going to go back to the lecture notes. So and show you, you know, what we did. What we did was calculate the NPV for different values of the discount rate. So we calculated NPV. So this is the NPV when the discount rate is 0. So you can think of it
Okay.
as no, that's one value. You know, when it's 0, it's 1,600. Remember, let's take this with us over here. So this is the table NPV profile, but you could also make a graph. I could do that in Excel too. I could show you, we can make a graph with it. So basically we're plotting. So this at 5%, oops. I think I have to make my 5% bigger. So this is like 10. This is like 20. And this is like 5. Okay, so this is 5%. This is 10%. This is 20%. This is 15%. And basically we found those values, and the way the function works, it's a smooth curve that goes down. And then it hits here where NPV is 0. So what does this graph say? The NPV rule always gives you the right answer, all right? What's the NPV rule? Invest if NPV is positive, right?
Mm-hmm.
So where is NPV positive on this graph? For what discount rates is NPV positive?
Anything before 23.3.
Anything before 23. So what does it mean? It means that the hospital or the HCO can comfortably pursue the project. It'll be profitable as long as their required rate of return is less than this. So this is like telling you, it's giving you a cutoff as well. It's telling you, you know what, you can only pursue the project as long as you don't want, you have a discount rate that's less than this. In other words, you can see this as, it's like the project's return on investment. It's saying, well, it's 23.3%. You compare that to your own discount rate or the interest rate you're using. So I call it the required rate of return. This is your own interest rate, but notice I didn't even have to write it down. I tried a bunch of different ones and found out that I will accept the project as long as my required rate of return is lower than 23.3. So it gives me a whole range of values to pursue the project. So what is the what's the reality of that? If a large organization is thinking of investing in a project, they're going to compare it to what they could get in financial markets if they invested it. And, you know, what they would be willing, what level of risk they're would be willing to take. So maybe they'll just invest it in some security. So they'll buy some bonds, or they'll buy some, what they think of like dividend paying stocks. And they'll get some return there with their investment. And they estimate that they could get about 15% return. So usually what we always compare to is the fact that, the stock market I should spell it out. Historically, returns about 12% on average. 12% over a long period of time. But if you look at all those years, because some years are bad years, there's some years are even worse years, and some years are really boom years, right? Boom years, where on average, historically, the return is about 12% per year. So for every dollar invested, they get 12 cents. Every $1 million invested, they get 100, well, what's that? 120,000. So that would be something to think about. Well, if we just invest in the stock market and we leave the money there for long term, we can get 12%. So what I'm trying to say is discount rates for firms are somewhere between that, 10% to probably less than 20%. So what it means is that it's likely that the firm will just pursue this project because of the fact that that's really high. So this is like a high return for the project. So you can think about it as the return for the project. So of course you're going to pursue that because that's better than you can get in the stock market. It's better than you can get in any kind of bonds or savings, right? So it's better than all that. So we should pursue it. That's how you think about it. So the IRR greater than the required rate, any of these you accept. So that's how we use the IRR. So there's two things here. Calculating it is one thing and interpreting it is another. Okay, so I'm doing both with you. So I don't want to lose you because, you're having trouble figuring out how to get it. So you can practice the calculating of it and also not forget how to interpret it. So this is really popular because it's actually, it is actually the most popular method. So we're going to spend some time on it. And that is because, like I say, you don't need a discount rate to use it. It actually helps you narrow down if it looks like a feasible project without a discount rate.
Sometimes the path of
Okay, so here I put, I'll fix this. I'll put some more details here like I did in class, but this is what you would do in Excel. This is what we did. Okay, so I have a new project here. Now, how is this different than the thing we just did? The project we just analyzed, how is this different?
3 years only.
Okay, yes. What else?
It's negative.
right? The cash flows are negative, and the initial outlay or the initial investment is
4,000.
4,000.
it's positive. Okay, so it's reversed. The values, the cash flows are reversed. Before I had a negative initial outlay and then positive cash flows, and now I'm reversing it. So we're going from what's called an investment project here, where you invest and then you see the returns, to here where you have
Plus.
money up front. So either you're financing the project, you've either borrowed the money or you've collected members or shareholders value, you know, they've invested up front, and then you're going to produce a product or offer a service as a result. So it's positive to negatives. This is known as a finance project. Does that make sense? So the other one is an investment project because you spend something and then you get something. This is the opposite. You borrow money up front, or you collect, you know, up front, and then you disperse, you pay out, you to offer the
Mhm.
services, you have to spend money, basically. So same technique to get the IRR. What's going to happen though is because the cash flows are reversed, the pattern is reversed, and the interpretation is going to be slightly different for the IRR. So why do I teach you all this? Because you need to know what the IRR is, but you need to know how to interpret it. It matters whether you have an investment project or a finance project in how you interpret it. So here's my, and look at the NPV profile. I'm going to put it aside with this one. This one was from before. So I'm going to lay that aside here so you can see what's the difference. What's the difference? No comments? So before it was positive and it went down and it crossed to become negative. The NPV or your profit went down to become negative. Here in the finance project, it starts as a negative and it goes up to become positive. So the signs are reversed, so the function will be reversed. It's going to go from negative to positive, whereas before it went positive to negative. And where will we find the IRR for this project? In here, the NPV crosses 0, so we expect to find it between 10% and 15%.
Okay.
Oh, sorry, did I do that right? Yes, 10% and 15%. So what will you do in Excel with that? How you're going to put that in Excel? I'm sorry, you're going to put, if I gave you that information, you put the original numbers in Excel and you ask for the IRR. That's probably the easiest way, is to just tell you that it's between 10 and 15. So you put these in Excel and find the IRR. Wonder if we just put it without making the profile, it'll just work. Let's see. Where'd everybody go? Are you guys there? Did you need a break?
No.
Okay, so let's go to Excel. I'm going to put the numbers in.
It took the values away.
Remember, you have to put the 0 in, right? 0.
So in this case, what's the guess?
Between 10 and 15.
Yeah, but how do you put that on Excel?
Well, let me write it up first.
Okay. Can we see your screen as you're working?
I'm just typing, I'm just making a table. I'm trying to share the numbers because if you don't see the numbers, how are you going to do it yourself? So let's see. That's my table. Now let's say I just did the guess, IRR, and just forgot about the NPV profile. I just put all these numbers in with a comma and just guessed. Well, I know it's between 10 and 5. It's going to work. So it works. But making the profile, make sure you're looking in the right direction. See why? Did you do it?
I'm still looking, I'm still trying to. So we're using 10%.
I just put 10, yeah. I wonder if it just worked for any number, because it's pretty straightforward. It might just work.
I got 14%.
Yeah, that's right. Wonder if it's gonna work no matter what I put there, which will be. Oh, it doesn't like a negative. Interesting. Oh, you know what? Maybe.
Because you know it's between 10 and 15. So maybe it's 15.
I'm just trying to see if I can just put it and not have to do the profile, but I think you still need it. It'll come out. All right. So it's 14. Now what do we do? What do we do with the 14.37? How do we interpret that? So let's look back at the graph. Let's look at what that looks like. Okay. Sorry. Let me share my iPad. So now it's backwards, right? Because I told you the profile will be backwards, or the cash flows are backwards, so the profile will be backwards. It's just rather than going down, it's going up. Now, how do you interpret this? What did we say? When is the project going to be profitable? Just look at the picture.
Then after 14.37%.
After 14.37%. So why is that? Because that's where the NPV will be positive. That's where the NPV will be positive. So what happened? Well, because the IRR, because the cash flows were inverted, the IRR interpretation will be inverted. What's happening is we're going to treat this IRR as we're going to call it the rate of financing as opposed to like the internal rate of return, the rate of financing. And we want it to be low. So we want it to be lower than the discount rate or the required rate of return set by the corporation or the firm. Okay, so any of these discount rates, as long as the firm has a required rate of return greater than 14.37, they should pursue the project. So you accept the project as long as the required rate of return is greater than, so we flip these around, okay? That will make the NPV positive. So all this goes back to the nature of what we're doing. We're saying, let the project break even. Where does that happen? The project breaks even here. And so as long as the firm expects a return 15% or more, this is a positive NPV project, and it's profitable and we should pursue it. All right, so that's the internal rate of return for investment projects and financing projects. And I have a summary statement here. If it's an investment project, and the internal rate of return exceeds what's required, you accept the investment, you accept it as long as it's an investment project where the first cash flow is negative, only one sign change. In other words, the rest are all positive. It's called a financing project, and you will accept the project as long as it's the reverse. The required rate of return has to be bigger than the internal rate of return. And it's called financing as long as the first cash flow is a positive and that there's only one sign change and the rest are all negative. So I feel like I've overwhelmed everybody because nobody's there. It's just TY. But unfortunately I have to continue. I guess you're going to watch the video later. So I'm just going to do one of these. I'm going to delete all of these. I'm just going to do one because I don't want to. This is a tool, right? It's just a tool. I don't want to be focused on the tool. I want to use the tool. I don't want to describe so much, but it requires to be able to interpret for different scenarios. You need to understand the mechanics of the tool. So look at this drawing here. So these are cash flows that go from negative to positive and then positive to negative. What this means is you're not going to get just a downsloping curve. So if it's an investment project, it's going to be a downsloping curve. If it's a finance project, it's going to be an upsloping curve. But if it's two sign changes or more, it's neither of those, okay? It'll actually be, if there's two sign changes, there could be up to 2 IRRs because it will curve. This function will curve. It'll curve up. Or it'll curve down. So things change and you need to know how to interpret, but I'm just going to show you one example and leave it at that because I don't expect you to be experts. But the point is that it's not just, in this case, we said accept if the IRR was greater than you require. And here you accept if the required rate of return is higher than the IRR. It's not so straightforward when there's a sign change. You actually have to make the NPV profile and stare at the curve. In this case, though, this is an exception. What would you do here if this was your curve? This was your NPV profile. What would you do? Accept or reject?
Accept if RRR is greater than IRR.
There are no IRRs in this problem. It never crosses the line.
Oh.
So what do you do? What is this curve saying? This curve is saying the NPV is always positive. So what should you?
Yeah. I'll take it if the NPV is higher, is greater.
The NPV is always positive no matter what.
I'll decide based on the greater NPV.
Well, no, there's
I'll
only
take the higher value.
Yeah, well, okay, so the discount rate is kind of determined by the firm, right? They don't get to pick, well, they pick it, but they don't just say, oh, I'm gonna have a high discount rate, so I have a high NPV. That's not the logic of it. It's like they base it on alternative investments. So they're gonna say, well, if we're gonna invest in the stock market, it should be around 12. If we're gonna expand our we're going to invest in our own services. We're going to duplicate our clinic space, or we're going to, so they're going to base it on their own company's return, their own risk of investing, of people investing in their company. They're going to use that discount rate. So the discount rate they use is based on a bunch of things, okay? And that's why we're trying to find a way to not have to calculate it, but it doesn't matter. Basically, it doesn't matter The NPV is always positive no matter what. So you should always accept this project. What about this one? What do we say about this one? Oops.
Always reject.
Always reject, always. NPV is okay. All right, but what if it crosses? What do we do if it crosses that line? So here's an example. Okay, sorry, I'll take the cash flows with me. So let me take the cash flows with me. So here are the cash flows. What would you say about this project? So I've done it already for you. These are the cash flows. It goes from negative to positive, then positive to negative. So I know that there are
Positive to negative.
up to 2 returns because it's going to curve. And let's say I gave you this. So here it is. Here are the IRRs. I gave everything. What do you conclude? How do you,
I'll accept when the rate is between the positive.
between what?
I'll accept when it's positive, and that's between 11.52 and 29.84.
Excellent, TY. Yes, you will accept this project as long as it's between. And it probably is. That's a reasonable range to accept. I mean, to expect your required rate of return between 12 and 30 is probably true. So you will accept this project. Okay, TY, I know you understand. I don't know about the others, but let's see if they come back. So I think I'm going to edit the notes and take out the rest and just leave this example. But basically, that's the idea. You are going to use the NPV to make your interpretation, but the calculating the IRR gives you like a boundary to look at. And you fall back on the NPV always. I have some more drawings. I can just show you some more. But we won't
I
do
have
all
a question about that. The 2 sign changes.
Yes.
So on the other slide, is it because it went from negative to positive to negative? That's what they mean by 2 sign changes?
Yeah, exactly.
Okay.
Thank you, Barbara. You're there. So what about this one?
Same way.
What do we say here?
I'll accept when it's positive. That's between minus 29.35 and 72.25.
Okay, so this is a mathematical result that you get a negative and you get a positive, and they're very, like, this is really high. Okay, this is almost like this case over here. Where it's like always positive NPV, right? It's almost, it's 72%. No one's going to have a required rate of return of 72% as their required rate of return. That's asking a lot. No, every dollar that gets invested, you get 72 cents, or every million, you get 720,000 return. That doesn't, that's not common, okay? It's very unlikely. And then this negative, nobody's going to use a negative rate of return because that doesn't even make sense. We're going to be in business to lose money. So this is a mathematical result, but to make the interpretation, you just use like common sense and you say, you know, accept this project, provided the required rate of return is between 0 and 72.25. But like I said, this is really high, and it's basically saying it's a positive NPV project all the time.
But what if it says it's positive from minus 29.35? We disregard that part?
I'm disregarding it because it's not reality. Like most people will
Okay.
not ever, no firm will say, oh, our required rate of return is negative. Basically, we're throwing money away. We're not getting a return, right?
Okay.
The negative. So that's why I started from here. But in general, this is just a really good project. You should pursue it because for all these, whatever discount rate you use, you're always getting a positive return. So it's like something that just will not fail. And you might have that if you have high demand for something and then you duplicate your services because of the high demand. You can't lose because you have the demand there. Okay, so that is IRR and NPV. I have another example here, but I'm going to change these notes a bit because I don't want you to spend too much time calculating. I just want you to do a little bit of calculations. I mostly want you to do interpretation. I want you to understand interpreting. This one is another one. How would you interpret this one? And then we'll talk about why it happens.
I'll accept for only above 33.96.
But also over here.
Yeah, and also below 8.05.
Yes. So what's going on? Let's look at the cash flows. I'll pull them over. So these are the cash flows. All right. So what is it? So what's happening? So look at the cash flows. This one is high. This one is high, and this one is high. So these are all very high, relatively speaking, right? This one's higher than all of them in the future. And then you have some mediocre value here. But so what does that mean? It means that for these set of cash flows to be a positive NPV, you should not discount something in the future so high. So that's why it likes low discount rates, right? So it prefers low discount rates, so this doesn't get diminished. But it also doesn't mind high discount rates because you got this, $660 up front, and you don't mind discounting these relatively high values a lot because they're negatives and they take away from our positives. So if we discount high, it diminishes these, and we don't care so much because this will be relatively higher. So that's why it doesn't care if it has high discount rates, and it likes low discount rates. But anything in between is omitted. So this is so just because of the way that the cash flows work out, right? And so that's how it works. So we've learned about internal rate of return for investment projects, for finance projects, and for multiple internal rates of return. And we've just looked at the case of 2 or up to 2 internal rates of return. How you find them, I won't expect you to find these. If I did, I would just give you, like we could do this. So here, for instance, I would give you something like this, and then you can use Excel to approximate. You want to try that? So try and see if you can get these two using these cash flows, and then we're going to go. You have like 10 minutes. So I'll do it as well. Don't forget the negatives in the right place. And then we'll finish these notes. We're going to talk about mutually exclusive projects, capital rationing, and profitability index. We'll talk about it next time.
When you put it in Excel, you have to put it as a chart, right? You can't.
So just put this in, just put, sorry, this, yeah, put this in. You should put it as a chart. It's just easier. Yeah, because
Okay.
IRR doesn't take the values.
Right,
It
okay.
only takes the cells.
Okay.
So let me do it as well.
So you took the numbers away.
Yeah, I can't see. Okay, there you go.
Sorry.
No.
No. I got to put them back in. Okay, I'll put them back up, you guys. I thought you copied them already. There you go. don't do these numbers here, right? Not these ones. These are the ones you want. The
Oh,
cash flows. The
Yeah.
cash flows.
oh my God. Okay.
The other numbers are the NPV profile, and it helps you find the guessing point. And you should be able to generate that, but it seems to slow us down. So if I need to, I'll just give that to you. But you should be able to calculate it yourself. Okay, can I do it now? Show you my Excel. I'll prepare my Excel.
Yes. Oh, enter. So it's a 50, It says I entered too many arguments. It's straight to 50.
Uh-oh, I hope it doesn't have an error.
It says I entered too many. We're using IRR, right?
Yeah, we're doing IRR. And then we're grabbing the values, all of them. And then we're putting a guess.
What's our guess?
Well, look at the other, the NPV profile. So what should your guess be according to the NPV profile on the right
You
side?
took the weight. Okay, NPV profile on the right side. It should be between
10 and 15.
10 and 15.
And it should be between 25 and 30. Now, let's see if it can work. So you got to put a number closer to 25 and 30. Otherwise, it'll iterate and keep getting this one. These are the answers if you got it right. 11.52 and 29.84. So going back to Excel,
I didn't get it.
The goal is to get the 12%.
yeah, like
Or-
11.5 to 12, yeah. So here's one of mine.
And you put, you had to use 11. So if,
Yeah, you can use 11. I used 11. You could use anything. You should go down just to stay away from the other value or iterate to the other value. So yeah, go below 11. Yeah, go below 11 point. Go to the lower end. So you see that it's between 10 and 15. Even trying 10 will work. It'll work. It'll work for 5. It should iterate towards it. Oh, sorry, I keep changing the wrong thing. Okay, wait. I'm changing here. So I'm gonna go to 5. Oh no, it didn't work. So you got to get close. Wow.
yeah, my 5 was 30%.
Yeah, you got to use it close. So you really need that table to get it right. So this is going to be, let's step through this. So there are since there are 2 sign changes, there are up to 2 IRRs. So we found one and we got to try and look for the other one. So I'm going to do the same thing, but I'm going to change the number. Now putting just 5 in there.
So you're using a rate of 11?
Yeah, the guess of 11.
Guess of 11.
But if I put something else there, if I put 20, oh, it still goes there. Where's the other
Gave
one
me
again?
12%.
Where's
So
the
let
other
me
one?
change the decimal.
Oh, I got to go higher. I got to go to 30.
Yeah, I got that.
Oh, why doesn't it change? What am I doing wrong? That's crazy. 40. Do I have to put 25? So it's having problems iterating, like it's doing it faster than we could. But it's not finding. If I put 30? I put 29. Keeps iterating.
So 29.
This is not good. So that's why, that's why I teach using the NPV profile, because this is not foolproof. This is terrible. So maybe it doesn't do 2 IRRs. Just like most calculators don't, it won't do it. I have to look it up.
It gave the same answer.
I shouldn't do that. What am I doing wrong? Maybe there's a different function. Hold on, let me
It gave
check.
the same answer.
Because usually I teach this with a calculator. I'm just going to Google it. Excel and multiple, that's what it's called, multiple IRRs. How to solve with multiple IRRs in Excel. And that didn't work. So there's like, how can there be more? How can calculate IRR function, multiple IRRs? Well, it's 8:30 and I said I wouldn't keep you past, but I'm going to clean up the notes and repost them. And I'll see about why we can't get the second one. I'm really surprised. I have to look it up because they have a lot of information here, and I'll share it with you. What a good source.
It
But
says to use modified internal rate of return when I Googled.
really, if I put an M?
It says to use, one way to deal with multiple IRRs is to use the modified internal rate of return. So MIRR.
Oh, you got to put other things in there. Values, finance, rate, reinvest rate. Oh, I don't know. I think I have to learn how to enter that. That's going beyond the scope. Basically, I just want you to be able to interpret it anyways. Yeah, so all right, so so I'll try and sort it out, but if I want you to interpret, I'll just give you that. I'll give you the results and then you have to interpret. So for instance, if I show you the result, how do you interpret? If I gave you this, how would you interpret? Can you interpret just looking at the chart? This
I would say I should invest between 11.52 and 29.84.
right. So as long as the firm's discount rate is between 15 and 25, this is profitable because the NPV is positive. That's exactly what you do. Great job, TY. Did you understand, Lydia, Barbara? We can see it right off of here. So if it gets, this is the most complex it can be. And if I can't get it out of Excel in an easy way, I'm just going to give you the answers and then you have to interpret. So it means accept the project or pursue the project as long as the required rate of return used by the firm is between these two numbers. And like I said before, that's not unusual. It's not an unusual range, so it's probably going to be accepted. Okay, so I'm going to revise these notes a bit. I'll post them and I'm going to post an assignment, your second assignment that will include some of this. Maybe I'll hold off on the capital budgeting just now, but just some questions around calculating the payback period, calculating the internal rate of return, how to interpret. And then we have just a couple other things for next week that I'll put on the assignment. So this week it is, I'm going to put up the notes for readings of chapter 11, which was budgeting. Why do I forget what it's called? It's called budgeting concepts. Okay. So we've been doing quantitative work to maybe operationalize what we're reading about. So you can actually, I don't know if it helps to actually solve problems and just talk about scenarios and possibilities. We're actually making it tangible by putting numbers to it. So, so work on that, what I put up this week, and next week, I think we're going back to cost management. I'm just going to look at the syllabus a moment. Because we did, yeah. Oh, planning budgets. Okay, so chapter 12, we're going to continue. We're going to continue with budgeting and then go back to cost management later on in November. Okay, so we're going to continue. We're going to stay with budgets for the next two classes after this. So you can continue with your review of chapter 11, chapter 12. Okay, bye, Barbara. Bye, Lydia.
Bye.
Bye, TY.
Bye, good night.
Good night.
Thank you.
Thank
Night,
you.
The darkness over here. Bye.